What's going on, Algebra 2 students? You guys are my Algebra 2 class, right?
No, we're Algebra 6.
Algebra 6. What's going on, Algebra 6 students? Let's get this party started. We're going to hit standardized tests, and I'm going over some of the answers with you guys on all of these tests. So let's take a look. You guys said that the second one was the hardest. Okay. I kind of feel like I would like to make it more interactive and have you guys come up and try the problems out and that kind of stuff. But I also want to get through this quickly. So I think that, is it right if I just do it? I'll do it. I'll go through it quickly. And if I finish early, you guys can leave. Unless you're staying for chemistry. Is that fair? Because if I can get through... Oh, wait. Is that better? I fixed your screen for you. All right. If I can get through all of my stuff that I want to cover for a standardized test, for this, you know, if I can get through both of these tests, which it took me an hour to do 15 questions last time. So hopefully I'm doing 30 questions now. I hope it's not going to take me an hour or 2 hours or whatever. But if I can get through that quickly, I can help you out with polynomial recap. And we can even talk about what's coming up next week on your final exam. Okay. I'm going to start off with question number one on standardized test part 2. And I'm not going to write the answer, or I'm not going to write down question 1, question 2, all of that kind of stuff. Did anyone think there was something wrong with last question test 2? There could have been something wrong. We'll take a look at it right now. All right. I think the problem was 3n plus 5 squared equals what? All right. Can you see that, by the way? Can you see 3n plus 5? Should I move it up? Sorry. There we go. All right. 3n plus 5 squared. All right. Foil it out. Literally, that's all you do. Just put 3n plus 5. 3n plus 5. Foil it. Anyone have any questions? First, outer, inner, last. This literally came off of an SAT question. All right. Some techniques I would like to show you because this is a technique that you should know how to do because it might make you quicker. So I'm going to do a little bit of a side note real quick. A plus B squared is simply A squared plus B squared. Yes?
Yeah.
Okay. I promise you I would put this slipper on your face. You told me that that's going to be true. That is never true.
Why not?
Don't ever do that. Ever. That is a boot to the face. BTF. Right there. Do you guys remember me saying boot to the face, right?
Yeah.
Okay. Look, here's the reason why. This is not true. Not true. Not ever true. I'll show you guys the slow way to do it then. And this is the last time I'm showing it because I'm actually going to make good on my threat of putting my boot in your face the next time you tell me that A plus B squared is A squared plus B squared. Fair? All right, you got fair warning. The reason being is because A plus B times A plus B, if you square it out, if you FOIL it out, you'll have A squared. The outers is plus AB. The inners is plus BA, which I'm going to write down as AB as well. Is that all right with you?
Yeah.
Plus B squared. A squared plus B squared, but there's a 2AB in the middle.
Okay.
So, when I asked you what is A plus B squared, and you told me it's A squared plus B squared, you're forgetting what we call the cross term.
Okay.
You're just not being careful. In fact, This is such an important equation that I actually want you to memorize this. If I have something plus something squared, that's equal to the first thing squared plus the last thing squared plus 2 times them together. Does that make sense? If I have something plus something squared, then that's the first thing squared plus the last thing squared plus 2 times the first and the last thing, all multiplied together.
Okay.
Fair enough? And the reason why I showed you that is because I can immediately jump to my answer, which would be 9n squared plus 25 plus 30n. Here's the first thing squared, here's the last thing squared, and here's 2 times 5 times 3 times n. So it's e. That's the answer. We cool with that? It's e, or whatever the last answer is. All right. I guess the point that I'm trying to get across is this. A plus b squared is not a squared plus b squared. You can even write down the acronym BTTF. Boot to the face, my friend. Got it? I know, because you kids and your crazy lingo is all about acronyms. Miss Sononini, do you need me to quiet down or?
Oh, sorry, am I too loud?
No. I can quiet down for your videos.
No, sorry.
Are you doing video only, no audio?
No, I'm doing video, but
Oh, okay.
we can learn some math in the background.
Talking about Mr. Dalde threatening to boot people in the face. The reason why I make such a big deal out of that is because there's certain equations that I want you to memorize, and I want you to I don't think I've asked you to memorize any equations, but I have made you use an equation so much that you kind of got forced to memorize it, like the quadratic equation, for example. That's kind of something that you'll see over and over again, especially when we cover rational functions. Got it? So when we cover rational functions, which is the next topic we're covering anyway, you're going to be doing a lot of that kind of stuff, the a plus b squared and that kind of stuff. So you're going to need to see that and recognize that immediately. Oh, I know how to do that. You'll also need to go backwards. Like if I gave you a squared plus 2ab plus b squared, you guys should be able to recognize, oh, wait a second, that's a plus b squared. Right? So you need to know that equation backwards and forward. Got it? All right. Next one. So yes, that was a shortcut. The next one I feel like is just a straight up plug and chug. X cubed equals 729. What is x squared plus square root of x? What is the cube root of 729? Anyone can do that on their calculator? I'm not very good at math in my head. Does anyone have a phone with Siri on it? Andre, can I borrow your phone? Oh, okay. Jenna's already got it for me. The answer is 9. Do you guys understand how to put in the cube root into your calculators? Do you know how to do this? I guess that's the real test. Yes, no? No, you don't? Okay. There is no cube root button usually on your calculators.
Right.
But this is the same as this. Just like the square root of 16 is the same as 16 to the 1/2 power. All right? And so, plugging that into my calculator, all I would need to put in is, what is 729 caret, parentheses, 1 divided by 3. Those are literally the buttons I would push.
Okay.
And then that would give me my answer of 9. Because 9 times 9 is 81, times that by 9, I guess is 729. Fair enough? All right. So x is equal to 9. So if I'm asking you this, then just plug in 9. What's 9 squared plus the square root of 9? That's 81 plus 3, right? Here's my answer, my friends. We good? Anyone confused as to how I got 9? I guess that's really the main question is how do you figure out what x is to begin with? And really it's a calculator question. Do you know how to use your calculator correctly? Now you do. Good. All right, moving on. Can I move on? Okay. Which of the following is a solution for x squared plus 25x equals 0? Okay. They gave you a bunch of options. Literally what I would do if you are completely lost on how to do this is I would take each of my options and plug it into here and see which one works. Make sense? Another route I would take is you could factor it. You could say, all right, well, is it all right if I pull an x out of both of these? Are these the same?
Basically.
Well, they're exactly the same because if I distribute this x back in here,
Yeah.
this would be x squared, and that would be 25x. That would be the same thing, right?
Yeah.
And remember, this is straight up factoring. Like, if this times this equals 0, then either this equals 0 or this equals 0. So what are my two answers? X equals 0 or x equals negative 25. Right? Like after we've been doing polynomials, this is kind of cake for you. Right? So there's your answer, negative 25. You cool? So what I'm showing you now is not necessarily, I don't want to just show you, here's the answer, here's the answer, here's the answer. I want to show you how to go about getting to the answer. And maybe your route is the best way. Maybe you're confused. What I think would be good for me to show you is how I would approach it. Because I have a lot of experience with math, and maybe I might find a route that is a lot quicker. All right? I'm going to try to explain to you multiple routes. The, oh my gosh, I forgot every equation route, and the, oh, here's the quickest way of getting to it. Because I think when you're taking a test, you're going to fall, each problem is going to fall into two categories. You're going to know how to do it, or you're not going to know how to do it. But you can get to the answer if you're in either school of thought. Does that make sense? Like, for example, the little tidbit I shared with you with, hey, if they gave you which one of these solves x, or is correct answer for x, and you do not know how to do this factoring thing, then literally just plug in all of your options into here and see which one ends up being 0. Makes sense. In fact, negative 25 totally makes sense in here because negative 25 squared is, I don't know what it is, but it's a big number, right? Minus, because if I have a negative 25, 25 times 25. So I think that my answer is negative 25. Immediately, my answer is right there. Got it? So you might not see my fast way of doing it, and maybe that would be good for me to show you, but it also would be good for me to show you how to do it if you forget everything, like forget how to do it, everything. One equation I would recommend you not forgetting how to do is the quadratic equation. It's probably one of the most powerful ones you can have with you when you're taking these tests. All right, this one's a little funky. X, there's a dot with a box around it, y is equal to x minus 2y squared. What is 5 with a dot and a box, negative 3? Did you guys see this one?
Mm-hmm.
Was it freaky to you?
Yes.
Okay.
Something multiplication squared.
This is totally and easy problem. The reason why it freaks you out is because you see a symbol that you've never seen before, and your brain goes to mush. Your brain is like, I've never seen that. I must be stupid. I'm too stupid to solve this problem. I don't know what to do. I'm freaking out. Right? Let me warm up with you. This is the easiest thing, I promise you. Let me warm up with you. Let's say f of x is equal to x cubed plus 2x. All right? This is something you're familiar with. What is f of 2? You don't need to tell me the answer, just tell me what the expression is. Or here, let's try f of 3. Let's do 3. What is that? You just do what?
Times 3 times 3. So 3x. No, not 3x. The x is a 3, then 2, 3.
So 3 cubed plus 2 times 3.
Yeah.
So you just replace all the x's with a 3. That's all you do. So what is f of 100? 100 cubed plus 3 times 100. Right? What is f of a happy face? All right, I've never seen happy face, but you plug in a happy face into there. Happy face cubed plus 3 times happy face. Got it? All right. What I'm doing here, all right, so you understand this concept, right? Not hard? What I'm doing here is I'm kind of making up a new function for you, and I'm writing it in a new way. I'm saying x box y is x minus 2y squared. So what is a box b? Let me ask you that. All you do is you just write down this thing all over again. But wherever you see an x, you put an a. And wherever you see a b, or a y, you put a b. Right? So that would be a minus 2b squared. Got it? Does this make sense to you? All it is I'm writing down exactly what they told me, but I'm just replacing the new things. We cool? So what is 5 box 3? Or 5 box negative 3? Well, that's 5 minus 2 times negative 3 squared. Was that confusing?
No.
That was the hardest part of the problem. You're done. Another thing that might freak people out is they forgot to put a parentheses around here, so it looks to them like, oh, that's 5 minus 2 minus 3. No, that's 5 minus 2 times negative 3. So then this becomes 5 plus 6 squared, which becomes 11 squared, which becomes 121. Is that the option? Yeah, 121. So, the key to this problem is when you see something you don't know, don't freak out. They probably threw it in there so that way it will make you freak out, but it's not really that hard. They're just giving you, here's the instructions. And then here's what I want you to do with those instructions. Just like if I give you a function, I say, here's the thing I want you, the machine I want you to put it in. And if I gave you different things, you just put it through that same machine. Does that make sense? So those of you who said, oh, I hated this problem, this one was so hard, it's not really that bad when you look at it, right? Okay, good. Maybe one of these days I should put in a math problem that's like, what is 5 Triton 2? Or something like that. You'd be like, oh my gosh, a Triton, I don't know what to do. It's just a symbol that I'm making up. Right? And I can define it however I want. I could have used a star. I could have used a happy face. Right? By the way, that Triton looking symbol is actually called a psi, which is a Greek letter that we use for waves in quantum mechanics. But For now, you guys just say, oh, that's just a symbol. He better define that symbol for me so I know what to do with it. Right? All right. F of x equals 2x squared plus 3. What is f of x plus h? Do you know how to do this one? There we go. After I just did that one problem with you, doing this one is almost like, oh, wow. All you're doing is just replacing wherever you see an x with a x plus h. By the way, I'm just curious, Ms. Sononini, do you recognize this? I'm just wondering.
Yeah.
You recognize like where this would become important?
Wow, when in calculus.
There we go. This is one of the keys to calculus. And the reason why I asked her is because she just aced calculus.
That would
And-
be
Oh, well, aced with a B.
She based it.
She based it. But believe it or not, if I ever teach you calculus or whenever you get to calculus, this is going to be one of the problems that we do. It's kind of a key thing. And I'll explain to you one day what's going on behind it. But don't freak out when you get to calculus because that's all we're doing. Anyway, all you're doing is replacing an x with x plus h. So really, my f of x plus h is equal to 2 times x plus h squared plus 3. This is 2 times x squared plus h squared plus 3. Everyone following so far?
a little.
Someone said BTTF. All y'all, BTTF. Boots to the face. Dude, x plus h squared is not x squared plus h squared. BTTF for you and you and you and you. How did you not catch it? Do you see that?
Yeah, I do.
You guys see how you guys just fell into the BTTF trap? What do I need to go in the middle?
The 3?
Plus 2xh
Oh.
plus 3. No, the 3's still out there, but it's not x squared plus h squared. You need to add the 2xh in the middle. BTTF to you, and BTTF to you, and you, and you. Seriously. It's a lot of boots in the face. You're lucky I wore slippers today. Don't have my boots today.
Okay. I mean, I have to take them off because it takes a while.
Alright, well here, do me a favor. Don't make that mistake again. I tell you what, I don't know it for sure, but if I have a chance, I'm going to trick you one more time with that. You better catch me. Or I will probably STTF. Slipper to the face. Alright? Anyway, distribute the 2 into there. 2x squared plus 4xh plus 2h squared plus 3. Is that? Yeah, that's the answer. I can't simplify this because I can't combine this into anything, so it's done. Me gusta. What does that mean? Does it mean I hate you?
No, it means I like.
Okay.
Isn't it? I think so.
Just no habla español. Are we good? Can I erase?
Yeah.
No habla español. All right. All right. Next one. Okay, this one. X squared plus 3x over x. Y equals. Now, I'll be honest with you. This one in particular is not something I've covered with you. And it is actually, this is actually falls under the category of rational functions. Why did I put this in your test thing? It's because I made a mistake. It's just as simple as that. But it's not hard. In fact, this actually might be a preview as to what's coming up in rational functions. So that way you realize, oh, wait a second, rational functions isn't going to be that bad. I actually kind of feel like polynomials wasn't that bad, to be honest with you. Rational functions is similar as long as you are good at things like that a plus b squared thing, you know, and you can factor like a beast. Anyway, can I just write down x plus 3?
Yeah.
Is that freaking you out?
No.
I basically took the x and divided each thing by x. X squared goes down to x plus 3, or 3x goes down to. So, yeah, I think somebody online is saying, well, technically you could say this is x times x plus 3, and then you have an x here and an x there, so then it becomes just x plus 3. Yeah, exactly. I just did all those steps in my head, which you can do in your head too, see? Can you graph x plus 3? What's the slope? 1. What's the intercept? 3. All right. Then you better choose this graph right here. I think that was the third graph. Got it? Welcome to rational functions, ladies and gentlemen. It's going to be that good. I promise you, actually, I'm not kidding you. This is rational functions. This is like the baby version of rational functions. Rational functions is what's going to... Remember how I told you guys... Remember how I gave you stuff like this, like x squared plus 3x plus 4, or let's say minus 4 or something like that. And I told you guys, hey, do you guys know how to factor this? And you guys factored it. You guys remember that? And I told you the best way to do these is if you do like a billion of these. If you do a lot of these problems, you'll get so good at them, they'll just be able to write it in, right? The topic that we're going to be covering, called rational functions, requires you to be so good at this that you're going to just know it right off the top of your head, right off the bat. Okay? So I'm just previewing for you what's going to come up in January. We're going to be hitting factoring like nobody's business, but we're going to be using it for something even deeper.
Okay.
All right? So, if you're not good at factoring now, you better get good at it. Or, if you're not good at factoring now, you will get good at it. How's that? All right, here's one that you might not have seen. Maybe you don't even know how to do this one. I'll show you how to do it. Factor that. That's what it's asking you to do. Have you seen something like this before? What about you online? Have you seen this one? All right. I'll show it to you in an easier version. A squared plus b squared is equal to a plus b squared. Correct?
I don't trust it.
No. In fact, all this is reverse of what I wrote down as boots to the face. Right? I just put the right side on the left side this time, right? But a squared minus b squared is equal to a plus b times a minus b.
That makes sense.
Yeah.
That is actually true. I'll prove it to you, but I'm letting you know it's true. I'm going to FOIL this side. A squared. Outers is negative AB. Good. Inners is plus AB. And last is negative B squared. You notice how we usually have to have that pesky cross term in there? Well, in this particular one, the cross terms cancel each other out. This is negative AB plus AB. Those kill each other.
Yeah.
So you end up getting A squared minus B squared.
Okay.
Okay? I want you to write down this formula. A plus b times a minus b is equal to a squared minus b squared. This is called the difference of squares. That's what the formula is called, difference of squares. And believe it or not, I did go over this with you. I remember specifically telling you the word difference of squares. Do you guys vaguely remember that? You guys are like the quietest bunch. Come on, talk to me.
Yeah.
Yes, you do? Or are you just saying that because you want me to get off your back?
I do.
All right. Difference of squares is a thing. The sum of squares does not exist. There is no such thing as the sum of squares.
Okay.
Difference of squares, that's an actual thing. Okay? Now, do you see a difference of squares situation up here?
Negative.
Well, I see a difference. That's good. Is 16 a square? 4 squared is 16. Good. What about this one? Is that something squared?
Go down to that symbol.
It's a to the 8th power squared,
Oh.
right? Because I have 16 a's, which means I could have a to the 8th power squared because a to the 8th times a to the 8th is 16 a's total. Does that make sense? So, applying my difference of squares formula, I'll take this plus this, put a parentheses around it, and then take this minus that. A8 plus 4 times A8 minus 4. And the question was asking, which of these following is an expression? Wait a second. Wait a second. Oh, okay. This wasn't one of the options. I'm looking at this and I'm like, wait a second, something's wrong here. This wasn't one of the options. It's because I'm not done. Do you guys see how I'm not done?
Yeah.
Why?
You didn't fill it
No, if I foiled it out, I'll get this, I promise you.
out.
I just took this and I factored it there. And I factored you going real quick using a formula.
Just be A8 squared.
What?
Wouldn't it just be A8 squared? Or
No.
Oh.
I'll show you where we got stuck in the middle. Can I factor this? Is this a square? Is 4 a square?
Yeah.
4 is a square, yeah. Is this a square? A to the
Oh,
8th power? Yeah.
Yeah, it is.
It's a to the 4th power squared,
Yeah.
right? So I can factor this. Can I factor this?
Yeah.
No. There's no such thing as the sum of squares. Can I factor this? Is this a square? 4. Yes. Is this a square? Yes. Can I factor this? Yes, you can, because there's such thing as a difference of squares. Does that make sense? Now, I'll show you what the difference of squares is. A4 plus 2, A4 minus 2, A8 plus 4. So I dropped this guy down because I can't break him down anymore. But this guy can actually break down into these two options. Do you see that?
Yeah.
So there's 3 factors of this. If I were to FOIL out all of these 3 things, I'll get this. What is the key to knowing how to do that particular problem? I think the key to knowing how to do that particular problem is memorizing this equation. Got it? Is there a trick to do this? Is there a trick to do this without knowing that equation? my answer is, I want to say no. Yeah. I mean, one of the things I would think you could do is you could take all of your answers and use polynomial long division, but that really won't help you. It just make things ugly and messy. So learn this equation down here. Got it? All right. That was a good problem. Oh, and it's those kinds of tricks that you're really going to learn pretty solidly when you get to rational functions. So again, when you get to rational functions, I want you to memorize those kinds of things. The a squared, the difference of squares formula, that's super important. Also the a plus b squared formula. It's not a squared plus b squared. It's a squared plus b squared plus 2ab in the middle, right? And you're never going to forget that. In fact, we'll call that the BTTF formula. All right, here we go. What's the next one? Oh, this one you guys should be very familiar with. ax squared plus bx plus c equals 0 if x equals 3/4 and x equals -2/5 is in this, are zeros of this function, then what is an expression for that? You guys understand? All right. You should be familiar with this because this is in what kind of form? This is in standard form, right? If I have it in this kind of form like this, actually I only need two of them because it's a second degree polynomial.
That'd be the
That's the, no, not vertex form, it's the factored form. You just did a homework on
I
this.
know.
Yeah? So, standard form, factored form, okay? If the numbers come out nicely, I can just say, oh, my answers is x equals -a, x equals -b, right? If the numbers can come out nicely. What ends up happening here is you end up saying, okay, the numbers didn't come out nicely. So what's the only way to approach this thing if I can't factor it where the numbers come out nicely? Quadratic formula. Let's pretend I put it through the quadratic formula, and here's my two answers. Okay? Then what should have gone in here? 3/4 and -2/5. I disagree with you. You got close though.
Aren't the x's supposed to be 3/4?
Huh?
-2.
4x minus 3.
Yes, 4x minus 3, but there's one thing that you miss that I kind of want to point on here. -3/4 and +2/5. Remember, because when it's in here, you take the opposite of the answer. Right? So this -3/4 translates to one of my answers being 3/4, and this +2/5 translates to one of my answers being -2/5. Does that make sense?
Yeah.
All right. Now, what you're saying is, oh, okay, well, if I multiply this thing by 4, then this would be 4x minus 3. And I multiply this one by 5, and I'll get 5x plus 2. Do you guys understand how I was able to just multiply this by 4? Do you understand why? Okay. All of you are saying yes. I have a feeling you don't. But fine, I'll explain it to you anyway because I just feel like you don't. I'm allowed to multiply this one by 4 because technically I'm actually multiplying both sides by 4. This times 4 and that times 4. You can't just multiply one thing on one side of an equation. You have to do it to both sides. The advantage here is the right-hand side is what?
0.
0. So when I multiply 0 times 4, it doesn't change. It's still 0. That's why I was able to, allowed to multiply this one by 4 and that one by 5. Now you guys see it. All right, good. So those are your answers. We cool? A rectangular parking lot is 3 feet longer than than it is wide. So, if it's, how do I find the area of a parking lot? Length times W. And if it's 3 feet longer, so this is how wide it is, and the length is L, which is W plus 3. Are we cool? What is the area of the parking lot? All right, well, W times, or W plus 3 times W equals 550. Then you just solve. W squared plus 3W equals 550. Do you guys know how to solve this problem? Yes, no, I don't. If you do, I'm going to move on. If you don't, I can show you at least the starting point. Go over it. All right, fine. Once I write it down, you guys will be like, oh, I know how to do it. Do you understand how I got here? Huh? Yeah? Okay. Now do you know how to solve for W? Yes? If yes, then what do you do?
Quadratic equation.
Quadratic equation. A is what?
1,
B is?
3,
C is?
negative 550.
Yeah. Yeah, that makes sense. Yeah. We cool? That's it. So all I did was I moved this 550 over to this side, and I made it look like something I'm familiar with. AX squared plus BX plus C. The difference, of course, you're not dealing with X, you're dealing with W's, so what? And that's it. That's the only difference. Are we cool with that? Remember, when solving, because this is a quadratic equation right here. When solving anything that has a polynomial to the degree 2, we can always solve it using the quadratic equation. That is our shotgun in our arsenal. It will always work. It might be ugly, it might be messy, but it will work. Garants, well, Barons, pull out that gun, boom, kill the fly. Got it? Do you guys understand my analogies now?
Yeah.
Yeah.
I think that they only make sense after I've explained, after I've like,
All of it.
at the end of the class. And you're like, I understand what the hell he was talking about in day 1. All right, moving on. I'm trying to go through this quick. Am I going too quick? Oh gosh, there's so many problems. All right, find a function where negative 5 is bigger than 5. Well, not negative 5 is bigger than 5, but the y value of the function when x is equal to negative 5 is bigger than the y value of the function when x is equal to positive 5. Do you guys understand what I just said?
Yeah.
Okay. Literally, to be honest with you, I would just plug it into each, because they tell you, okay, when f of x is equal to 6x squared, when f of x equals to 6, when f of x is equal to 6 over x. And then they have f of x is equal to 6 minus x cubed. So they gave you all these different options. Just plug it in. If this were f of x, then what is f of negative 5?
Wait, first one?
Yeah.
Oh.
That'd be 6 times 25. Right? What is f of 5? 6 times 25 as well. Is this number bigger than that number? No, they're the same. That's not a good choice. F of x equals 6. What is f of negative 5? This one's a funny one.
6.
6. What is f of positive 5?
6.
6. What is f of 100? For this function right here.
6.
Hint, f of x equals 6. What is f of a happy face? 6. It's always 6. So is f of negative 5 bigger than f of 5? No. You guys know how to do this problem now? I'm going to move on. Is it alright if I just didn't tell you which one's the right answer? I just showed you how to do it. You know how to do it, right? Cool? It's this one. That's the right answer. Alright, moving on. I don't feel like this was... Was this standardized test hard?
I was just phased.
I think that for me, the point I'm trying to show you is that I literally did get these off of the standardized tests. And Sophia's saying they're a little overwhelming at first. With a regular test, you're going to be faced with about 60 to 100 of these kinds of problems. They're not hard. They require you to know your math and require you to know it quickly. And I think the reason why a lot of people suck on these is because they get overwhelmed. They allow themselves to get overwhelmed. But when you sit down and think about it, I did teach you all of this stuff. I felt like you even learned it pretty well. Or at least I taught it to you. I feel like I taught it to you well. Anyway, moving on. R plus 2, R minus 3 equals 0. What is a following possible value for R? Can you tell me what are the two? Negative 2 and positive 3. There we go. Any questions? By the way, positive 3 is not an option on this multiple choice, so the answer must be
2.
negative 2.
Yeah.
Negative of whatever's in there. Right, you know, this is cake because we learned polynomials. All right, here we go.
Is this number 12?
I think the one I'm doing now is number 12. A rectangular garden has a length x and a width y, okay? Draw the picture. Length x, width y. The garden length is reduced by 3 feet, so that's x minus 3. And the width is extended by 2. What's the area? Any questions? Seriously, any questions? All right, done. I apologize if I'm writing this down too quickly for you. I want to go through this quickly because I feel like this is kind of, I don't know, is it boring? Am I being boring here or?
No.
Okay. Just want to make sure you're not bored. All right. 3x squared minus 1, x squared minus 4. Which is an equivalent expression? Or which of the following is the product of this? Do you know how to do this one? What are your thoughts? Tell me how to do it. Yes, you know how to do it?
Just use the bathroom.
Huh?
I need to use the bathroom.
Well, you had to use the bathroom.
Yeah.
Okay, before you use the bathroom, tell me how to do it. You keep nodding your head. You keep nodding your head. Yeah, I understand. I just want to make sure. I'm not trying to call you out or anything. No, you don't? Okay, you can use the bathroom.
Dude, it's not coming to my head right now.
I'll tell you the answer. Foil. You're just foiling. That's it. It's still the same process of foil. You might be dealing with some things that you're not necessarily used to, but it's still foil. First is 3x to the 4th power. You understand how that works? The 3x squared times x squared is 3x to the 4th. Cool? The outers is minus 12x squared. The inners is minus x squared. And the last is plus 4. Combining this, I get 3x to the 4th power minus 13x squared plus 4. I almost want to ask, If this were a polynomial, what is the degree of this polynomial? 4. What's the leading coefficient?
3.
3. What is the y-intercept? Positive 4. You're used to this. You've seen this. See? Look, leading coefficient's 3, degrees 4. Y-intercept is 4. I almost would say that the way I solved this is I looked at this and I asked myself those 3 questions. And then I looked for the answer that had those three characteristics. Done. No foiling required. Okay? All right. You can go to the bathroom.
I'll just wait it out.
You sure the bathroom's like right over there? I don't want to say they're easy, but maybe they're easy when I look at them and I show you how to do them, but they're not easy when you're taking the test. Oh, okay, here we go. A plus y, a plus z equals 0. What is the answers? Negative y and negative z. Correct. That was an option.
That's an option.
That is negative y and negative z, yes. You got that answer right.
Minus 1.
Remember, when it's in factored form, you just take the negative version of whatever it is. In this case, you're not used to seeing a's, you're used to seeing x. All right, get over it. I just changed the letter. Deal with it. And you're used to seeing numbers here, not letters. Well, okay, but if there were a letter there, you'd know what to do with it. Does that make sense? All right. And the last one before we get to take a break. How's that? We covered this in, what time did I start? 12:45? Whew! It almost took us an hour. I don't know if I could do the next one in half an hour. I'll try. If that's all right with you. Do you feel like this is helpful to you? Is this helpful? Okay, all right. The last one. X squared plus Rx plus 12 is equivalent to x plus 3 times x plus s. What is the value of R? Okay. It's saying here that the answer is 7. And this is the last problem that you guys told me, hey, this last one is wrong. And I actually would agree with you. This one is wrong. It can't be 7. I mean, think about it. If we're factoring this, what are the only numbers that can go in here?
Negative 3.
Well, they have to have, these two has to multiply to 12. If I plug a 7 in here, that won't multiply 3 times whatever to get 12. Oh, I see what the problem is. Oh, okay, this isn't so bad. Actually, okay, now this makes sense to me. Now, okay, yeah, all right. I think this is solvable. Let's see how to get the answer. X plus 3, x plus, what has to go there? 4. Why 4?
3 times 4 is 12.
Right, because they have to multiply that to that, so 4. Got it? FOIL this. X squared plus 4x plus 3x plus 12. Got it? So x squared plus 7x plus 12. That has to be 7. because that had to be 4. And for some reason, I was thinking, when I looked at the problem and you guys told me, hey, there's a mistake with it, I immediately looked at the answers and I said, well, that number can't be 7. Yes, but that one can be. And that's what we were looking for. Right? So, yes, I got it right. I put the right answer in the one. You just screwed up, Jenna. And I joke about that because you rarely ever screw up. And, you know, I like to point out when you do. I'm kidding, I don't. But, yeah. I don't know. If that hurt your feelings, I apologize. Anyway, you guys want to take a 5-minute break? Or do you guys want me to just burn it right through? I don't mind burning it right through. We can do a 5-minute break. I got an answer of no. So,
No burning.
no burn it right through or no 5-minute break? Oh, okay. All right. Jenna is asking if we can recap, if we can kind of cover a little bit of 8.1, which I think, was that due today?
Yeah.
Okay. Can we cover a little bit of 8.1 and then we can go back? Is that what you want to do in your break? Is cover 8.1? Because she has to go at 2. So she wants to take a look at this. I'm assuming you want to take a look at the last 2 problems because that's the one you said you had trouble with. All right, I'll tell you what. Let's take a look at those. How's your brains? Sierra, you're out?
Yeah.
Okay.
I was only gonna stick around for the second test. Then we can do it.
Okay. 8.1, polynomial 8.1. It is an 8-pointer. Okay. Oh, okay. X cubed plus 6x squared plus 3x minus 10. Okay. All right. Here's what I would do. Oh, I see. So I gave you the same function, and I just asked you different questions over and over again. Is that right? For polynomial 8.1? Okay. And the last 2 were a little bit funky. Did I? Oh, and in the previous question, in question 6, I told you what one of the x-intercepts is, so you should be able to use polynomial long division to find the other 2 x-intercepts. Okay. Then what were all 3 of your x-intercepts? Negative or positive 1, negative 2, and negative 5. Okay. Then what I would do, because I was looking at that problem, I'm like, that's impossible to do. But then when I realized that it was a part of a bunch of other problems, I understand. Okay, so your problem was x cubed plus 6x squared, x cubed plus 6x squared plus 3x minus 10. Was that it? Yeah. And then in a previous part of the problem, I told you that x minus 1 is a factor. And then you use polynomial long division to find x plus 2, x plus 5. Yeah? Okay. And no one has questions on how to get there. Is that right? Cameron? You do you know how to get from here to here?
Yes.
All right, good. And the zeros are x equals 1, -2, and -5. So those are our points of interest. 1, 0, -2, -3, -4, -5. Those are our points of interest. And then what did I ask you? I asked you when are they positive? When are they positive? Okay. All right. There's a right way to do this, and then there's a trick to doing this. You want to see the right way to do it? I'll describe it to you at least. How's that? The right way to do this is to realize that, okay, those 3 points, 1, 2, and 3, they will break my number line into 5 different quadrants. Do you see all 5 of them? There's one here, and one here, and here, and here. Oops, I made a mistake. 4 different quadrants. There's numbers that are smaller than -5, numbers between -5 and -2, numbers between -2 and 1, numbers between 1 and infinity. We cool? And then what I would do is I would, wait, you guys are saying no. What are you saying no to? I don't understand. Bradley, why did you say no? Oh, okay, all right. Sorry, I try to make sure. All right. So you have 4 different quadrants, and then what you could do is you could choose a number that's in this quadrant and plug it into here or here, but this one's easier. Plug it into here and see whether it's positive or negative. And you can just test it. We cool? That's the tedious, slow way of doing things. But that's the way I taught you how to do it. We cool with that? What's the quick, clever way to do these things? Or you could graph it. Sophia's saying you could graph it. Yeah, absolutely. What kind of polynomial is this? What degree? 3. You're allowed to talk. Please, talk. All right. What's the coefficient in front of it? Positive 1. So it's positive, right? My graph's going to look like that, right? It's going to cross at -5, -2, and +1, right? So when is the y part of this graph positive? Between here and here, and here and above. So my answers are -5 to 2, -2. So between the intervals of -5 and -2, and also 1 to infinity. That's your answer. I think that's what I told you guys the right answer was. Does this make sense to you? Yeah. What is the maximum value between -6 and -5? This last one is a little bit, I guess the thing is I didn't teach you guys how to do this. But it's not that bad. I didn't officially show you how to do this. And this is a calculus thing as well. Okay. Let me show you how to do this one. This one's actually not bad. Let's go back to the graph. Between -6 and -5. So if this right here is -5, and this right here is -6, what's the y value at -5? 0. Good. What's the y value at -6? I don't know. Is it a positive or negative number? Let me ask you that. It's a negative number. It's something lower than 0. Cool? I could tell you exactly what it is. I just got to plug in 6 into here and then figure out what that is and calculate it all out, and it'll be kind of a mess, but I'll tell you. Give me a second. All right? But I don't really need to know. I guess the question is, if your x value is anywhere between -6 and -5, which one will give you the biggest y value? At -5, because that's at 0. Good. That was easy. I think the answer is 0. Or is it -5? I'm not sure. What did I say? What is the maximum value? So I asked you, what is the y value? So the answer is 0. Now, the reason why I told you where calculus comes in is because I happen to give you a nice interval. It was between here and here. If I told you, what is the maximum y value between -5 and -2, then can you point to it? Yeah, it's right here. Can you figure out where that is? No, that's what it's hard. That one's harder. That's where we need calculus. In fact, would you like for me to show you the first step of what to do? I'll show you. When you see it, you'll be like, oh my goodness. If this is f of x, then the first step to figuring out where this maximum value occurs is I need to find f of x plus h. So you plug x plus h into here, here, and here. Remember I showed you that this has something to do with calculus? This is exactly what you do. We cool? But I didn't give you an ugly interval like that. I gave you one over here. What is the biggest number, what is the biggest y value that comes out of these, any x between here and here? We cool with that? All right. Chemistry class starts at 2:15. I have 20 minutes, 25 minutes, maybe 20. Yeah, I have 20 minutes to cover chapter 3 test, which is (24) problems. It took me an hour to cover 15 problems. What do you want me to do? You want to stop now and say, hey, Mr. Daldy, can you just give me the answers to the other ones and not show me how to do them all? Do you want me to go over a few of them, the specific ones that you guys had trouble with? You want to just go now?
I have chemistry, so I'm here, so.
All right. Get out of here. Algebra class is done. I will see you next year. Because next week, there are no finals. There are no classes. They are final exams. Then you have winter break. And then I'll see you in January. Oh, maybe I'll take this next few minutes to kind of talk about what's going to be on your final exam. Sound fair? In fact, I'll do one better than that. How's about this? I'll show you one problem that will be on your final exam. I'll just show it to you. Let me take a look at it real quick. And I'll tell you what, I'm going to stop the recording.